Welcome to the next session of subject engineering maths. Now we were in chapter 7, that is numerical methods. So let us start the session with classroom workbook from question number 18 onwards. RK method of order 4. RK method of order 4 is used to solve the equation dy by dx equal to y minus x. RK method of order 4. RK method of order 4. The initial condition is y of 0 equal to 2. Step size, that is h value as 0.1. The value of y of 0.1 up to 3 decimal places is blank. Up to 3 decimal places. So here h value is given as 0.1. H value is given as 0.1. We need to find y of 0.1. So that means y of 1h. That means value of y in first iteration only. If you want to find y value in first iteration, so we must take index value k as 0. So to get value by RK method of order 4, I must find 4 parameters. They are k1, k2, k3 as well as k4. Now let us see the value of k1. k1 equal to h into f of x0 comma y0. So h value is 0.1. f of x0 y0 is y0 minus x0, because this is f of x comma y. F of x comma y is y minus x. So f of x0 y0 is this. This is 0.1 into y0 minus x0. What is x0? x0 is 0. y0 is 2. So y0 minus x0 is 2. Therefore, this is 0.2. Now the value of k2 is h into f of x0 plus h by 2 comma y0 plus k1 by 2. So this is h value is 0.1 into f of x0 value is 0, h value is 0.1. So therefore this is 0.1 by 2 comma y0 value is 2. 2 plus k1 by 2. This is 0.1. So therefore this is 0.1 into f of this is 0.05 comma this is 2.1. So therefore this is 0.1 into f of x comma y minus x. So 2.1 minus 0.05. So let us calculate this value. So this is 2.1 minus 0.05. This is 2.05 into 0.1. So this is 0.205. Therefore, the value of K2 is like this. Next, we find K3 value. So here K3 equal to h into f of x0 plus h by 2 comma y0 plus k2 by 2. So this is h into f of x0 value is x0 plus h by 2. Anyhow, this is 0.05. y0 value, that is 2. y0 value is 2. 2 plus k2 value 0.205 divided by 2. So let me simplify this. This value is 0.1 into this divided by 2. So at first let me simplify this 0.205 divided by 2. This is 0.1025 plus 2. So therefore this is f of 0.05 comma 2.1025. Therefore, this is 0.1 into this is 2.1025 minus 0.05. So 2.1025 minus 0.05 into 0.1. So this is 0.205. So we got K3 value like this. Now after that we find K4. The value of K4 is H into f of x naught plus H, comma y naught plus K3. So this is H into f of x naught value is 0, H value is 0.1, f of 0.1, comma y naught value is 2 plus K3. So therefore y naught plus K3 becomes 2.205. 2.205. Therefore, this becomes H value is 0.1 into 2.205 minus 0.1. Now, let us simplify this. 2.205 minus 0.1 into 0.1. This is 0.210. Therefore, the value of y1 equal to y naught plus delta y. But delta y is nothing but 1 by 6 into k1 plus, let me write out k value here. So here delta y value is 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. So therefore this is 1 by 6 into k1 value is, we got k1 value as 0.2 plus 2 into this. So 2 times 0.205 equal to 0.41 plus 2k3. This is k3 value. Of course, we got same. This is 0.41 plus k4 value. This is 0.21. So let me add all this. 0.41 plus 0.41 plus 0.2 plus 0.21. So therefore, the value of k is 1 by 6 into this summation gives me 1.23. So 1.23 divided by 6. It gives me again 0.205. So therefore, the final value of y1 is y naught plus delta y. So this delta y again we are getting as this one only. So this we call it as k, because delta y we can call it as k. Don't compare this k with index k values. So if you have any confusion, you can write directly delta y only. Right? So therefore y naught value is 2. So 2 plus 0.205. So this is 2.205. Therefore this is the value of y at the end of first iteration. So you need not feel about this, because RK method of order 4, it involves a lot of evaluation. Only patience is required. Otherwise it is simple thing. So calculate all these values very carefully, because if you want to get delta y, it requires K4. K4 requires K3. K3 requires K2. K2 requires K1. So evaluate all these K values very carefully. Right? Next we move to question number 19. The values of a function f of x at 5 discrete points are given below. So x values are like this: 0, 0.1, 0.2, 0.3, 0.4. F of x values are like this: 0, 10, 40, 90, 160. So f of x values are given at 5 discrete points. Using trapezoidal rule with a step size of 0.1, the value of integral 0 to 0.4 f of x dx is, it's a numeral question. So x values are, 5 values of x are given, corresponding y values are given. This is y naught, starting value, this is last value. The difference between consecutive x values is 0.1. So h value is 0.1. Therefore, this value is integral 0 to 0.4 f of x dx. This is nothing but h by 2. By trapezoid h by 2, that is 0.1 by 2. Sum of first and last y values. 0 plus 160 plus 2 times sum of remaining y values. We have 3 values. They are 10 plus 40 plus 90. 10 plus 40 plus 90. So therefore this expression gives, this is 1 by 10. So this is 1 by 20 into this is 160 plus 2 into 140. So this is 1 by 20 into 160 plus 280, 440. So this value is 22. Therefore, the value of this by using trapezoidal rule is 22. Now we discuss question number 20. For a function f of x, the values are given like this: x values, f of x values, 0, 1.0, 0.2, 1.24, 0.4, 1.56, 0.6, 1.96, 0.8, 2.44, 1.0, 3.0. So x values are 1, 2, 3, 4, 5, 6. X and their functional values are given. The value of the integral 0 to 1 f of x dx equal to, according to trapezoidal rule. So this is starting, these are all y values. So this is starting y value, this is last y value, and these are middle values of y. The difference between consecutive x values is 0.2. That means step size h value is 0.2. Therefore, this is h by 2. That is 0.2 by 2 into sum of first and last y values. 1.0 plus 3.0 plus 2 times sum of remaining y values. So add these 4 numbers. So they are 1.24 plus 1.56 plus 1.96 plus 2.44. So therefore this is 0.1. This is 4 plus 2 into, now let us add these values. 1.24 plus 1.56 plus 1.96 1.24 plus 1.56, that is equal to 2.8 plus 1.56, that is equal to 4.36 plus 2.44. So it is 6.8. So therefore this is 1 by 10 into, this is 4 plus 6.8 into 2, 13.6. So therefore this is 17.6 by 10. This is nothing but 1.76. Now let us discuss question number 21. Values of f of x in the interval 0, 4 are given below. X values are 0, 1, 2, 3, 4. F of x values are 3, 10, 21, 36, 3, 10, 21, 36, 55. Using the Simpson's one-third rule with the step size, that is h value 1, the numerical approximation rounded to the second decimal place of integral 0 to 4 f of x dx. So we need to find out this integral using Simpson's one-third rule with the step size is 1, because the difference between consecutive x values is 1. So the formula for this is h by 3 into x plus 4 into o plus 2 into e. This is y0, this is y1, y2, y3, and this value is y4. So h value is 1. 1 by 3 into x means sum of first and last y values. That is 3 plus 55 plus 4 into odd index y1 and y3. Sum of y1 and y3. So it is 10 plus 36 plus 2 times even index, that is 21. 2 into 21. Therefore, this is 1 by 3 into 58 plus this is 46. So 46 into 4, 24. 4 4 16 plus 2, 184 plus 42. So therefore, this is 58 plus 42, 100. 100 plus this is 284. So let us simplify this. 284 divided by 3. The value is 284 divided by 3. This is 94.66. 94.666. Now let us discuss question number 22. Simpson's one-third rule is used to integrate the function f of x equal to 3 by 5 into x square plus 9 by 5 between x equal to 0 and x equal to 1. Using least number of subintervals, the value of the integral is. What is my function f of x? This is 3 by 5 into x square plus 9 by 5. So between x equal to 0 and 1, we need to integrate this with the least number of subintervals. Now, what is the least number of subintervals required for one-third rule? It is 2. But when you look at the integrand function, it is a second degree polynomial expression. We know that for all second degree polynomial expressions, Simpson's one-third rule gives 0 error. Therefore, instead of doing the value by one-third rule, you can go for direct value. So therefore, this is integral 0 to 1 f of x dx is integral 0 to 1 3x square plus 9 into this is 1 by 5 dx. So therefore, this is 1 by 5 into this one is x cube plus 9x. Limits are from 0 to 1. So this is 1 by 5 plus 1 by 5 into 1 plus 9. So the value is 2. So therefore, even if you solve it by Simpson's one-third rule by taking least number of subintervals 2, you must get 2, because it is a second degree polynomial expression. Error will be 0. E1 by 3 will be 0. That means original value must be same as V1 by 3. So therefore, V1 by 3 must be equal to original value. Okay, note this. Now let us move to question number 23. Simpson's one-third rule is applied to evaluate the integral minus 1 to plus 1 3x square plus 5 dx 3x square plus 5 dx with a subinterval size h value 1 will give. Options are like this: error greater than 1%, error between 0.01% and 0.1%, error between 0.1% and 1.0%, and the last option is the exact result. Now this is a second degree polynomial. So therefore the Simpson's one-third rule gives exact value for all second degree polynomials. Therefore the error value by using one-third rule will be 0 because the integrand is a second degree polynomial. You need not worry about h values. Irrespective of h value, Simpson's one-third rule always gives 0 error when the integrand is a second degree polynomial expression. Therefore error will be 0. So the error will be 0 means exact result. Therefore option D is right. Next question. Question number 24. In the interval, closed interval 0, pi, the equation x equal to cos x has options are like this. No solution, exactly one solution, exactly two solutions, and infinite number of solutions. Let us work out this. So this equation, we should know how many solutions are possible for this equation in this interval. Now I can take P of x equal to x minus cos x. This is equal to 0. Now this is a continuous function in this interval because this is a polynomial expression. We know that all polynomials are continuous in all intervals. Cos x is a curve whose graph is continuous in closed interval 0, pi. So by properties of continuous functions, its difference is also continuous in the same interval. So therefore this is continuous in closed interval 0, pi. Now let us calculate P of 0. That means function at the endpoints. P of 0 is 0 minus cos 0. It is minus 1, negative. P of pi. So this is pi minus cos pi. But cos pi is minus 1. So this becomes pi plus 1, which is greater than 0. So the function is continuous in closed interval 0, pi, and function takes opposite signs at the endpoints. Therefore, by intermediate value theorem, P of x equal to 0 has at least one root, in open interval 0, pi. Open interval 0, pi. So at least means it can be one, maybe finite number of solutions or infinite number of solutions, more than one. Let us see. At least one. But in the option it is given as no solution. So option A is wrong. So actually this is one curve, this is one curve. Let us draw the graph of this function. So x-axis, y-axis. So this is 0. And say for example this is pi by 2 and this is pi. Now cos x value, this is curve x. So the line is making an angle 45 degrees with positive x-axis. Basically this is a combination of two curves, y1 equal to x, y2 equal to cos x. Now my intention is in how many places between 0 and pi these two curves will intersect, and that gives number of solutions, right? So therefore this is the graph of y equal to x. Let us draw the graph of cos x. Cos 0 is 1, cos 90 is 0, cos pi is minus 1. So it will be like this. This is minus 1. So the curve will be like this. Like this. Therefore, this cos curve and this curve intersects it only in one position. At only one position. Therefore, this equation will have exactly one solution. Exactly one solution in closed interval 0, pi. Right? Note these points. It is a simple application of intermediate value theorem. The session is over. Thank you so much. With this, we have finished all chapters, chapter 1, 2, 3, 4, 5, 6, 7 of engineering mathematics with complete classroom workbook. Thank you so much.